Students, today we are going to start inverse of 3 by 3 matrix. So let's write inverse of 3 by 3 matrix by the adjoint method. The inverse, let's write the definition. The inverse of a 3 by 3 matrix follows from the relation matrix A times adjoint of A times adjoint of A matrix is equals to adjoint matrix A times matrix A is equals to determinant of A times I. This relation is true for any square matrix, A whose determinant A is not equals to 0. So here A times adjoint of A matrix is equals to adjoint of matrix A times A matrix is equal to determinant of A times I, and then for the inverse, this determinant of A should not equals to 0. If there will be determinant of A will be 0, then matrix does not exist. So now we are going to solve some problems, and then we will solve inverse type of problem also. So let us start the problems related to this exercise. Now problems. Question number 1. Suppose if A is equals to, we can write 1, 2, 3, 0, 1, suppose 4, and then 2, 3, 0. This is a matrix A, and matrix B is equals to, suppose minus 1, 2, 1. Similarly 3, we can write 3, suppose 0, minus 1, and then 2, 1, 0. A and B are these two matrices. Then prove that. Then prove that AB transpose is equals to B transpose times A transpose. How to prove this one? Students, this is question number 1 of this exercise. Now solution. We have to find at first, here is product. We have to multiply A and B matrix. and then we have to find the transpose of AB matrix. Here we have to multiply transpose of B matrix times transpose of A matrix. Now let's multiply at first A and B matrix solution. Here A is equal to, solution here given A is equals to 1 2 3 0 1 4 and then 2 3 0. This is matrix A, and the given matrix B is equals to -1 2 1 3 0 -1 2 1 0. This is matrix B, A and B. Now AB is equals to, now matrix AB, product of AB is equals to matrix A 1 2 3 0 1 4 2 3 0. This is A matrix times matrix B is -1 2 1 3 0 -1 and then 2 1 0. Now how to multiply these two matrices? You know the multiplication of matrix. Now we can multiply here. This is equals to, this is 1 times -1 is -1. We have to multiply this row to this column. So 1 times -1 is -1 plus 2 times 3 is 6 plus 3 times 2 is again, we have 6. Similarly, this row to this column, second column. So 1 times 2 is 2 plus 2 times 0 is 0 plus 3 times 1 is 3. Similarly, this first row to third column. So 1 times 1 is 1 plus 2 times -1 is -2 plus 3 times 0 is 0. Similarly, we have 0, the second row multiplied to the first column. So 0 times -1 is 0, 1 times 3 is +3, 4 times 2 is +8. Similarly, we have 0 times 2 is 0, 1 times 0 is +0, 4 times 1 is +4. Similarly, we have 0 times 1 is 0 and 1 times -1 is -1, 4 times 0 is +0. We have again 2 times -1. This last row multiplied to the first column, second column and third column. So 2 times -1 is -2, 3 times 3 is 9, 0 times 2 is 0. Similarly, we have 2 times 2 is 4 plus 3 times 0 is 0 plus 0 times 1 is also 0. Similarly, 2 times 1 is 2, 3 times -1 is -3, so 0 times 0 is +0. This is the multiplication. Now after calculating this, we'll get 6 6 12 -1 is 11. 11 here is 5 and then here is -1. So 11 5 -1. Similarly, we have here 8 and 3, it became 11, and this one is 4 and -1, 11 4 and -1. Similarly, we have next one is 9 minus 2 is 7 and 4 and then -1, 7 4 -1. This is the product of AB matrix. Now we have to find the transpose of AB matrix. Before this, we have to find B transpose and A transpose. Now this is equals to, we have to multiply. This is first column multiply to first row at first. So -1 times 1 is -1, -1. Similarly, 3 times 2 is +6, and then 2 times 3 is +6. Similarly, -4, this first row to second column. -1 times 0 is 0, -3 times 1 is +3, 2 times 4 is 8. Similarly, we have -1 times 2 is -2, 3 times 3 is 9 plus 9, and then 2 times 0 is plus 0. Now this second one row multiply to first column at first. So 2 times 1 is 2 plus 0 times 2 is 0 plus 3 times 1 is 3. 2 plus 0 plus 3. 2 plus 0 plus 3. Similarly, the second one, 2 times the second column, we are going to multiply. 2 times 0 is 0, 0 times 1 is also 0, 1 times 4 is 4. So 0 plus 0 plus 4. Again, this second row multiply to third column. This third column is this one. So 2 times 2 is 4, and 0 times 3 is 0, 1 times 0 is also 0. 2 plus 0 plus 0. 2 plus 0 plus, once again, 2 times 2 is 4. 4 plus 0 plus 0. Similarly, we have the last one row multiply to first column, second column, and third column continuously. So 1 times 1 is 1, minus 1 times 2 is minus 2, 0 times 3 is 0. So 1 minus 2 plus 1 minus 2 plus 0, 1 minus 2 plus 0. So next one, 1 times 0 is 0, minus 1 times 1 is minus 1, 0 times 4 is 0. So 0 minus 1 plus 0. Next one, 1 times 2 is 2, minus 1 times 3 is minus 3, 0 times 0. So 2 minus 3 plus 0. So this is B transpose times A transpose. Let's find this. Now this we can write, this is equals to, so this 6, 6, 12 minus 1 is 11. 8 plus 3 is also 11. 9 minus 2 is 7. Similarly, 2 plus 3 is 5, and then this one is 4, and this is also 4. And here is minus 1, here is also minus 1, here is also minus 1. Now this one is B transpose A transpose, and this one is A B role transpose. So these 11 11 7, 11 11 7, 5 4 4, minus 1 minus 1 minus 1, these two are equal. We can see these two are equal, therefore we can write, therefore LHS is equal to RHS. Left hand side is equal to right hand side. Therefore A B whole transpose is equals to B transpose times A transpose. In this way, here is proved that. So in this way, this problem is proved. We solve this problem by this way. Students, now we are going to solve another one question. Question number 2. Find the adjoint and inverse. Find the adjoint and inverse of, we can suppose, one matrix. We can give 3 by 3 matrix. Suppose 1, okay, minus 1 1, 2 1 minus 3, suppose, and then 1 1 1. This, find the adjoint and inverse of this matrix. This is our question. How can we solve? Solution. Solution. Let, we have to let at first, let A is equals to this given matrix 1 minus 1 1, 2 1 minus 3 1 1 1. This is a matrix A. We let it. Then determinant of A is equals to determinant. How to find the determinant? 1 minus 1 1, and then 2 1 minus 3 1 1 1. We have to find the determinant of this matrix. So this is equals to 1 times, this is plus at first, 1 times this and then this row and column omitted. So 1 minus 3 1 1 1 minus 3 1 1 here. Then there is, this is plus, you know, this one is plus and this one is minus, this one is also plus. We set up like this one, or we have to write minus 1 to the power I plus j. With this calculation also we can find the sign of either plus or minus, but if we use this system it will be more easy. So minus times minus 1, minus times minus 1 times this, when if we'll omit this and then this row and column, then it's remain 2 minus 3 1 and 1, 2 minus 3 1 and 1. Similarly the last one is plus this one is 1 times here this and then this we omit, so 2 1 1 1, 2 1 1 and 1 here. Now this is equals to 1 times 1 is 1, 1 minus plus, when it goes up there will be 1 minus sign. 3 times 1 is 3, minus plus 1 times, here is 2 times 1 is 2, and then minus times minus is plus 3, plus 1 times 2 times 1 is 2, minus 1, 1 times 1 is 1. So here this is equals to, this is 4 plus this one is 5 and then plus this one is 1, so is equals to 10, which is not equals to 0, so we can write so A inverse exists. If the determinant is 0, then A inverse does not exist. There is no solution. So A inverse exists. Now we have to find cofactor of A11. That one is A11 is equal to cofactor of A11. Cofactor of A11 is equals to, here is cofactor of A11 is, there is 1, this is first row and first column, A11 means first row first column, so here is 1 minus 3, this and this also omitted, 1 minus 3 1 1, 1 minus 3 1 and then 1. So this is equals to 1 times 1 is 1, minus plus 3 is equal to 4 we have. Similarly A12 is equals to cofactor of A12 is equals to, cofactor of A12 is this one, this is minus, and here is again minus 1. This one cofactor of minus, then this and this one is out, 2 minus 3, here 2 minus 3 1 1, 2 minus 3 1 and 1. So its answer is, we have here 2 plus 3 is equals to 5, and here is minus, so here is in bracket minus, so here is minus 5. Similarly A13 is equals to cofactor of A13 is equals to cofactor of A13 matrix. Our matrix is 1 3 is this one, so this is plus minus and this one is plus, so plus is not necessary to write. So we have this and this out, 2 1 1 1, 2 1 1 1. So we have this is equals to 2 times 1 is 2, minus 1 is equals to 1. Similarly, let's find the other cofactor. This one now, this is cofactor of A21. A21 is equal to cofactor of A21 is equals to A21 is this one. Here is A21 is, this is minus sign because A21 is second row, minus 1 to the power I plus j we have here. This minus 1 to the power I means, so here is 2 and j means 1. 2 plus 1, here is minus 1 to the power 3, so it is minus 1. So this one is plus and we say this one is minus. Easily we can say this one is plus, this one is minus. So we can calculate like this one, plus minus alternatively. So here is minus times, here this 21, cofactor of 21 is this one column and this one row is out, minus 1 1 1 1, minus 1 1 1 1 we have. This is equals to minus times minus 1 and then minus 1 is equals to minus 1 minus 1 minus 2, it became plus 2. Again cofactor of again A22 is equals to cofactor of A22 is equals to cofactor of A22 is, we have here this one, A22 is this one. So this row and then this row, यो जुन element छ त्यसको सिधा हामीले हेर्ने हो, यो row and then यो column चाहिँ out भयो, 1 1 1 1 बाँकी रह्यो. So we have here 1 1 1 1, here 2 plus 2 is 4, so it's positive plus, no need to write anything. So this is equals to 1 times 1 is 1 and 1 times 1 is minus 1, 1 minus 1, so it became 0. Similarly, cofactor of A23 is equal to cofactor of A23 is equals to, here cofactor of A23, here will come one negative sign because this is third one, 2 3, 2 plus 3 is 5, so minus 1 to the power 5 is minus 1, so here minus, so this column and this row is omitted, so we need 1 minus 1 1 1, 1 minus 1 1 1, we need this one. So its answer is minus times 1 1 times is 1 plus 1 is equals to minus 2. Similarly, A31, it means cofactor of A31 is equals to cofactor of A31 is 3 plus 1 4, here is positive sign, so this one is 1, 3 1 is this, so this row, this column and then this row is out, so minus 1 1 1 minus 3, minus 1 1 1 minus 3, so this is equals to, we have minus 3 times minus 1 is 3, 1 1 minus 1, so is equals to 2. Again A32 is cofactor of A32 is equals to 3 plus 2 is, it's 5, so 5 is minus 1 to the power 5 is minus, so this one is here is this, so this column and then this row is, this row and this column is out, so 1 1 2 minus 3, 1 1 2 minus 3, so its answer is minus times minus 3 minus times minus 3, 3 times 1 is minus 3 times 1 is minus 3, minus 2 times 1 is minus 2, so this one is minus 5 times minus is plus 5. Now again cofactor of A33 is equals to cofactor of A33 is equals to 3 3 is 6, so here is, this one is we check it again once here, plus minus plus minus plus, or if you want to check from here, plus minus plus minus plus, so we can write direct plus here, and then we have to omit this row and this column, so 1 minus 1 2 1 is left, so 1 minus 1 2 1. So after calculating this one, 1 times 1 is 1, so minus comes here when it goes up, then minus 2 times minus 1 is plus 2, so this is equal to 3. Now we found all the cofactors. Now we have to collect it all, we have to centralize this one, and matrix of cofactor of A. Now we are going to write matrix of, therefore matrix of cofactor of A is equals to, we have to write our first A11 is cofactor of A11 is 4, and then next one is minus 5, and the next one is 1. Similarly 2 1 is 2, and 2 2 is 0, and 2 3 is minus 2. Similarly 3 1 is 2, 3 2 is 5, and 3 3 is 3. This is the cofactor of matrix A. We have to find adjoint matrix also he asks. So first we are going to find the adjoint of A. Now adjoint of A is equals to transpose of this matrix. This means 4 minus 5 1 2 0 minus 2 2 5 3. Transpose of this matrix is equals to, transpose of this is 4 2 2 in here column, we have to convert in row 4 2 2. Similarly minus 5 0 5 in column, we have to convert in row minus 5 0 5, and then 1 minus 2 3, 1 minus 2 3, we change row to column. This is transpose matrix. So this is called the adjoint matrix. This is the answer of adjoint matrix. Now we have to find inverse matrix also. So A inverse is equals to adjoint of A divided by determinant of A. Adjoint of A divided by determinant of A. So our determinant of A is 1 by 10. 10 is determinant, so we can write 1 by 10 times adjoint of matrix is, this is 4 2 2 minus 5 0 5 1 minus 2 3. This is the answer of our question. We can open by 10 also, but if we open by 10, it will be 2 by 5, it will be 1 by 5, it will be also 1 by 5, it will be 1 by minus 1 by 2, it will be 1 by 2, here 1 by 10. So here we can open by 1 by 10, or we can put this same answer, this answer. Students, in this way we found the adjoint matrix and inverse matrix. I think you feel this easy. You can practice other more question like adjoint and inverse matrix. Students, now we are going to solve another one question, that is question number 3. In question number 3, we can set up one matrix. Okay, if A is equals to, suppose a matrix 3 by 3 matrix 2 4 3, similarly 2 3 4, and 5 2 6. Suppose this is a matrix A, so that so that first number, so that in A the sum of given matrix and its transpose, sum of the given matrix and its transpose is symmetric matrix, is a symmetric matrix. And the next one also, number B, the difference of the difference of given matrix and its transpose, and its transpose is a skew symmetric matrix. Skew symmetric matrix. Now, how to show this one? How to prove this? Here we have A is a given matrix. So at first we have to know what is meant by symmetric matrix and what is meant by skew symmetric matrix. We already discussed about this one. I think you know already. पक्कै थाहा छ हैन त? अब हामी यसको सोलुसनमा जाँदै छौं. Solution. We have here A matrix is 2 4 3 2 3 4 5 2 6. This is a matrix A. Now A transpose matrix is A transpose is equals to, we have to transpose this 2 2 2 5, row 2 column 2 2 5 4 3 2. So here is 4 3 2 3 4 6 3 4 6. This is A transpose matrix. Now first number, here number A, the answer of number A is the sum of given matrix. The sum of given matrix is A and its transpose plus A transpose. The sum of given matrix A and its transpose means A transpose is a symmetric matrix. So let's find at first this matrix and then we'll check either this one is symmetric matrix or not. So here we have A means we have 2 4 3 2 3 4 5 2 6 plus A transpose is we have 2 2 5 4 3 2 3 4 6. Let's add these two matrices. So 2 plus 2 we can write in matrix form. We should not write directly, so let's write 2 plus 2 and then 4 plus 2 4 plus 2. Similarly 3 plus 5 3 plus 5. So here 2 plus 4 2 plus 4 3 plus 3 and then 4 plus 2. Similarly we have 5 plus 3 2 plus 4 and then 6 plus 6. We have this is equals to 2 plus 2 is here 4 and then 2 plus 4 plus 2 is 6 and then 8. Similarly we have here 2 plus 4 6 6 and then also 6. Here is 8 and here is also 8. 4 plus 2 6 and then 6 plus 2 6 plus 6 12. This is A plus A transpose matrix. Now transpose, we have to find transpose of this one. Now A plus A transpose of this transpose is equals to, so here there is 4, here is 4 6 8, so have to write 4 6 8, this row to column, and then the 6 6 6 6 6 6, and then 8 6 12 with transpose of A plus A transpose. Here is A plus A transpose and A plus A transpose of again transpose matrix. These two matrices are, check, let's check, these two matrices are equal, either they are equal or not. Check it once again. 4 6 8 4 6 8 6 6 6, here is also 6 6 6 8 6 12, here is also 8 6 12. Isn't a magic? Yes. So let's write, since A plus A transpose is equals to A plus A transpose of transpose, A matrix and transpose of A matrix are equal, like the same. So the sum of given matrix and its transpose is symmetric. We have to prove symmetric matrix in this way. This one is proved, this first part is proved here. Students, you know about symmetric matrix. If transpose of A is equals to matrix A, then we say that types of matrix is called symmetric matrix. Here is also, if we think this all is A and then transpose of A, so A matrix is equal to transpose of A matrix, so this is called symmetric matrix. Now we have second part, the difference of given matrix and its transpose is skew symmetric matrix. You know about skew symmetric matrix. If you don't know, you observe here, don't go anywhere. Now for B parts, we have to find the difference of given matrix and its transpose. So A minus A transpose is equals to, A is here 2 4 3 2 3 4 5 2 6, minus A transpose is 2 2 5 4 3 2 3 4 6. Let's subtract this. Now this is equals to, we have 2 minus 2 minus 2 4 minus 2 3 minus 5, and then next one is 2 minus 4 3 minus 3, and then 4 minus 2. It's very easy. 5 minus 3, 2 minus 4, and 6 minus 6. This is equals to 2 minus 2 is 0, this one is 2, and this one is minus 2. Next one is 2 minus 4 is minus 2, this is 3 minus 3 is 0, 4 minus 2 is 2, 5 minus 3 is 2, 2 minus 4 minus 2, 6 minus 6 is 0. Here diagonally is 0. Now we have to find again transpose of that one. Now A minus A transpose of transpose is equals to, there 0 2 minus 2, so we have to write this row to column, all row to column, or column to row. So 0 2 minus 2, and then again minus 2 0 2, and then 2 minus 2 0, 2 minus 2 0. This is transpose matrix of A minus A transpose. Now this is equals to, can we take minus? If we take minus common here, then minus common, suppose minus 1 is common, then here is 0, this 0 1 is 0, so minus is taken common, so here is 2, and then here is plus 2, so if we'll take minus common, here is minus 2. So same here, here is minus 2, and then here is 0, and then minus is common already, so here is 2. Here is minus common, so 2, here is 2, minus common, so there is, here is plus sign, so here are plus means minus times minus, so one minus is here and another minus is here, minus 2, and then 0 is same 0. This is equals to minus times 1 is minus, minus times, what does this mean? Is this same or not? Check once. 0 2 minus 2, and then minus 2 0 2, minus 2 0 2, and then 2 minus 2 0 2 minus 2 0. These two matrices are equal. This is same. So it means this matrix. This means this A minus AT matrix. A minus A transpose matrix. So here we got, therefore A minus A transpose of transpose is equals to minus times A minus A transpose matrix. So these two are equal. Now we can write, since this A minus A transpose of transpose is equal to minus times A transpose this one, so the difference of given matrix, and its transpose, and its transpose, difference of given matrix and its transpose is a skew symmetric matrix. In this way we prove this one also. I think you know what is meant by skew symmetric matrix. Here this transpose is equal to minus times A, or A transpose is equal to minus A, and then that types of matrix is known as skew symmetric matrix, and we prove this question. Now we are going to solve another one question. Now let's start another one question, that is different types of question again. Question number 4. Prove that, let's take one matrix. Suppose 1 minus 2 3 0 minus 1 4 minus 2 2 1. This is one matrix, and let's take another one matrix. Suppose 9 minus 9 8 minus 5 minus 8 7 minus 4, and then we have to think minus 2 2 minus 1 are inverse of each other, inverse of each other. So how to solve this question? This matrix and this matrix are inverse to each other. You know, how can we show these two matrices are inverse? We have 2-3 methods to show inverse of these two matrices, but easiest one is we are going to solve solution. At first, let A is equals to the first matrix 1 minus 2 3 0 minus 1 4 minus 2 2 1. This is A matrix, and B is equals to minus 9 minus 8 minus 5 minus 8 7 minus 4 minus 2 2 minus 1. A and B. Now AB is equal to, now AB is equals to, students, why we are going to find AB? हामी किन AB find out गर्दैछौं? किनकि हामीलाई यो थाहा हुनुपर्छ कि we have to know AB is equal to BA is equals to I. If this condition occur, then we can say these two matrices are inverse to each other. Otherwise, हामी यसको इन्भर्स छुट्टै निकाल्छौं, त्यसपछि यसको इन्भर्स निकाल्दाखेरि यो म्याट्रिक्स आउँछ. त्यस अवस्थामा पनि हामी म्याट्रिक्स इन्भर्स हो टु इच अदर भनेर भन्छौं. अहिले भने हामी AB निकाल्छौं अनि BA निकाल्छौं. दुईटै चाहिँ के हुन्छ, यो हाम्रो चाहिँ I आउँछ. त्यसपछि हामी दिस टु म्याट्रिक्स आर इन्भर्स टु इच अदर भन्छौं. हेर्नुस् है त, AB is 1 minus 2 3 0 minus 1 4 minus 2 2 and then 1. This is A. And next one is B matrix is minus 9 minus 8 minus 5 minus 8 7 minus 4 minus 2 2 minus 1. Let's multiply these two matrices. This is equal to 1 times minus 9 is minus 9, and then minus 2 times minus 8 is plus 16. 3 times 2 is minus 6. Similarly, 1 times 8 is minus 8. 1 times minus 8 is minus 8. Minus 2 times 7 is minus 14. 3 times 2 is 6 plus 6. Again, 1 times minus 5 is minus 5. Minus 2 times minus 4 is plus 8. 3 times minus 1 is minus 3. Similarly, this second one, this to this first column. So 0 times minus 9 is 0. Minus 1 times minus 8 is plus 8. 4 times minus 2 is minus 8. Similarly, 0 times minus 8 is 0. Minus 1 times 7 is minus 7. 4 times 2 is plus 8. Similarly, 0 times minus 5 is 0. Minus 1 times minus 4 is plus 4. 4 times minus 1 is minus 4. Similarly, minus 2 times minus 9 is minus 18. 2 times minus 8 is minus 16. 1 times minus 2 is minus 2. Students, here we have here is plus 8. So here should also plus 8. So it's not minus 8. So here is also it's plus 8. When it became 8, then this first, first हामीले यो रोले फर्स्ट कलमलाई मल्टिप्लाई गर्यौं, त्यस्तै फर्स्ट रोले सेकेन्ड कलमलाई मल्टिप्लाई गर्दाखेरि 1 times 8 is here is plus 8. And then यो फर्स्ट रोले थर्ड कलमलाई हामीले मल्टिप्लाई गर्यौं, त्यसपछि फेरि हामीले यो सेकेन्ड रोले फर्स्ट कलमलाई मल्टिप्लाई गर्यौं, सेकेन्ड रोले सेकेन्ड कलमलाई मल्टिप्लाई गर्दाखेरि हेर्नुस् त 0 times 8 is 0, and then again minus 1 times 7 is minus 7. 4 times 2 is 8. It's correct up to now. Here यस्तै यसले फेरि थर्डलाई मल्टिप्लाई गर्यौं हामीले यसरी. फेरि हामीले के गर्यौं भन्दा यो फर्स्टले फर्स्ट हामीले कलमलाई मल्टिप्लाई गरेका छौं. minus 2 times minus 2 times minus 9 is plus 18. And then minus 2 times minus 8 is minus 16, and 1 times minus 2 is minus 2. Again, first यो हेर्नुस् त, यो लास्ट हाम्रो थर्ड रोले सेकेन्ड कलमलाई मल्टिप्लाई गर्दाखेरि minus 2 times 8 is minus 16, and then 2 times 7 is plus 14, plus 2 times 2 is 4. फेरि हेरौँ यसलाई हामी 8 times minus 2 is minus 16, 7 times 2 is plus 14, and then 1 times 2 is, here is 2. Again we have minus 2 times 5 is 10, it's plus 10, and then 2 times minus 4 is minus 8, and then 1 times minus 1 is minus 2. Here is 1 times minus 1. 1 times minus 1 is minus 1. So this is the multiplication. Sometimes we will be confused while multiplying, so we have to very careful on the sign. So here is 9 and then 6, it became 15, and then 16. Here is 1. So here is 6 and 8 became 14, minus 14 is 0. Here is 8 and then minus 8, plus 8 and minus 8 also 0. Here is 8 minus 8, 0, 0, and then here is 8 minus 7 is 1. 4 minus 4 is here 0. Again here 69, 2, it became minus 18, plus 18, here is 0. And then here 16 minus 16 is 0, and then here 8, 1, 9, 10 minus 9 is 1. So this is equals to, this is identity matrix. This is I. So AB is equals to I. Students, look here, AB is equals to I. Now we have to find BA. Just look here, again BA is equals to BA. What is B? We have B is 9, 8 minus 5, 9, 8 minus 5, minus 8, 7, minus 4, minus 8, 7, minus 4, minus 2, 2 minus 1, minus 2, 2 minus 1. This is B. And then again A. What is A? A is this one, 1 minus 2, 1 minus 2, 3, 0 minus 1, 4, and then minus 2, 2, 1, minus 2, 2, 1. This is B and this one is A. Let's multiply these two again. Now this is equals to, यसको multiplication हामी यहाँ हेरौं. Here 9 and then 1, this first row multiplied to the first column. So 9 times 1, this is equals to, here is BA. BA is equals to 9 times 1 is 9, 8 times 0 is plus 0, and then 5 times 2 is plus 10. Here is, once again, here students, here is minus 9. Here is minus 9, so here also we need minus 9. So minus 9 times 1 is minus 9, and then minus 5 times 2 is plus 10. Again this times this, so minus 9 times minus 2 is 18, plus 18, and then 8 times minus 1 is minus 8, and 5 times minus 5 times 2 is minus 10. Similarly, minus 9 times 3 is minus 27, 8 times 4 is plus 32, and then minus 5 times 1 is minus 5. Similarly here, minus 8 times this second row multiplied to the first, second and third column respectively. So minus 8 times 1 is minus 8, 7 times 0 is plus 0, and then minus 4 times minus 2 is plus 8. Again minus 8 times minus 2 is 16, minus 7 times minus 1 is minus 7, and then minus 4 times 2 is minus 8. Similarly again, minus 8 times 3 is minus 24. So 7 times 4 is 28, and then minus 4 times 1 is minus 4. Again, minus 2 times 1 is minus 2. 2 times 0 is plus 0. 1 times minus 2 is plus 2. Again, minus 2 times minus 2 is plus 4. 2 times minus 1 is minus 2. And then 1 times minus 2 is minus 2. Again, minus 2 times 3 is minus 6. Minus 2 times 4 is plus 8. And then minus 1 times 1 is minus 1. So this is a matrix BA. This is equals to, here is 9 and then 10. 10 minus 9 is 1. 1, and then here is 18. Minus 8 and 10 minus 18 plus 18 and minus 18 0. 27 minus 5. Minus 27 minus 5 is 32, plus 32 and minus 32 0. So here is also minus 8 and plus 8, it became 0. So 16, 7 and 8 became 15. 16 minus 15 is 1. 24 minus 4 is 20. Minus 24 minus 4 minus 28 plus 28 is 0. So here is minus 2 and plus 2, it became 0. Here is 4 minus 2 times 2, minus 2 minus 2, 4. It's also 0. And 6 minus 1, minus 7 plus 8 is 1, plus 1. So this is equals to 1 0 0 0 1 0 0 0 1. This is identity matrix I. Therefore AB is equal to BA is equals to I. Here is BA is equal to I, and here is, we have here AB is equal, we have already done, AB is equal to also I. So AB is equals to BA is equals to I. So the given matrix, given matrices are, so the given matrices are inverse. हामीलाई दिएको म्याट्रिक्सहरु चाहिँ इन्भर्स इच अदर भनेर हामी लेख्दै छौं. आर इन्भर्स इज other, because AB is equal to BA is equal to I. Students, यसरी हामीले यसको समाधान गर्यौं. तपाईहरुले यो हामीले दिएको एउटा म्याट्रिक्स, यो म्याट्रिक्सको इन्भर्स निकाल्नु भयो भने यो म्याट्रिक्स आउँछ, अथवा यो म्याट्रिक्सको इन्भर्स यसरी निकाल्नु भयो भने पनि यो म्याट्रिक्स आयो भने पनि यसरी इन्भर्स इच अदर भनेर तपाईले अर्को मेथड पनि प्रयोग गर्न सक्नुहुन्छ.